Hi, welcome to the video guys. My name is Pushpinder Gill and today we are going to do a video on number systems, that is a video on odds and evens, right? So there are a lot of questions that you get on odd numbers and even numbers in any exam that you give, whether it's GRE, whether it's GMAT or whether it's CAT or even SAT. Whichever exam you give, you will definitely find a lot of questions on odds and evens, right? So it's better that we have a separate video for it. So before we start, this would be the web address, that is perfect-score.com. Make sure that you explore more about us. There is lots and lots of exciting stuff to come out here, right? And this would be our Facebook page. Don't forget to like us on our Facebook page, that is facebook.com/perfectscores. And this would be the web address for you to send me your valuable feedback, right? So send us your valuable feedback. We would love to hear what you think about us, right? So let's go ahead and get started, guys. So, I'm going to start as usual every video. I'm going to start with the concept. What exactly the concept that is used when it comes to odds and evens? It has a very basic concept, but again, this basic concept can be put to very, very brilliant use and the question can become really, really difficult. So before we even start, I think it's better that we know that if you add any odd number to any odd number, it becomes an even number, right? So you had 3 plus 5, that is equal to 8. So let's suppose if I say that, so I'm just going to clean my board here. So if I add an odd number plus an odd number is actually equal to an even number, right? Similarly, an even number plus an odd number or the vice versa is actually equal to an odd number, right? Even number into any integer, right? So I'm talking about integer and not a fraction. Even number into any integer is actually equal to even, be it even or be it odd. And the odd into odd is always going to be odd, right? So suppose, this works for subtraction as well, plus and minus and plus and minus. Similarly, it's possible for me to divide an even number by an odd number. It's possible and get an evenly divisible answer, like 6 by 3. I will get 2. But it's never possible for me to divide an odd number by an even number. Now, why is that? Because even number has minimum one factor of 2. It has minimum one factor of 2, which an odd number never has. I suppose you know what is an odd number, what is an even number, right? An even number is a number which is divisible by 2, right? And an odd number is something that is never divisible by 2. It's not divisible by 2. So it's possible for me to have an even number by an odd number and yield an integer, but it's not possible for me here. Now I understand it's possible for me to classify any integer as even or odd, right? So it's possible for me to classify any integer as odd or even, right? So it's actually a better way of distributing things. So when it comes for me to actually consider, let's suppose 10 consecutive integers, I can consider them in terms of even and odd. Just like prime numbers, 1 is not prime. Just like let's say positive numbers, 0 is not positive. So you can classify every number to be even and odd. In fact, every integer to be even and odd. Every integer will either be even or will either be an odd number. So you must be thinking about, hey, what about 0? Well, 0 is an even integer. Alright, so you got to remember that 0 is an even integer, right? So I suppose you're understanding all this, right? So in a general way, you can write any even number as 2n, right? Where n can be any integer, and you can write any odd number as 2n plus 1 or 2n minus 1, right? So this is the way you can generalize any odd number. This is the way you can generalize any even number, right? So suppose you're understanding all this, whatever I'm doing here, guys, moving forward. Well, most of the questions are, they use 0. It's very, very special to these questions. Now, why is that? Because 0 is an even number. It's an even integer, right? So I'll just state the rules of 0 here. I think it's very, very important that we state the rules. It's neither positive, it's nor negative. It's actually a non-negative integer, right? It's neither positive nor negative. it's actually a non-negative integer. Second thing, it's actually an even integer, right? So 0 is an even integer, right? So that's there. So these are the rules of 0 that is concerned with the with even and odds, right? So there's no better way for me to show you my thought process just by doing some questions. That's very, very important that you plug in numbers when the question asks which of the following must be true. Now most of the questions would be which of the following questions, right? Most of the questions would be which of the following questions. And I suppose you know when the question asks you which of the following must be true, what do is you plug in your own number, right? So you plug in your own values. So make sure that you do that whenever you have questions telling you which of the following, right? So suppose you're understanding this, guys. Moving forward, let's go ahead and do some questions on it. Now it says that it's m and n are integers and m plus n plus m. So that is going to be 2 times m plus n is odd, right? Which of the following must be odd? Now as you know that m is an integer, which means 2 times m is going to be an even number, right? Because m is an integer, so 2 times m is going to be an even number. So for the sum to be odd, n will have to be equal to odd. I'm sorry, these are in terms of m only. I forgot to change that. Just gonna write it here. Okay. So for this sum to be odd, n will have to be odd. That means this over here is my answer, right? So that's there. So you can even say that let's suppose m over here it's actually equal to 2, right? And n is equal to 3. Okay. Then 2 plus 3 plus 2 is equal to 5 plus 2, which is 7, which is actually an odd number. It's satisfying my fact. These two values are working. So what I can do is I can actually eliminate my answer option. It says which of the following must be odd. You would say m is odd? No, because m is equal to 2. You say n is odd, can be my answer. What about m plus n? So m can be 2 also and m can be 3 also. It doesn't matter at all. Why? Because m can be even and m can be odd. Every time it is going to give me a odd number, right? So m plus n can be 3 plus 3, that is 6. That means this is eliminated. M into n can be 2 into 3 again. That can be eliminated. And m into n plus n, that is m into n plus m. So that can be 3 into 2 plus 2, which is again an even number. That means this is also eliminated. Hence B over here is my answer. So you can either go for this direct approach, quicker but risky, right? Or you can go for this approach, takes longer but safer. So it's up to you what you want to try on, right? So I suppose you're understanding this point over here. Okay. All right. Now let's go ahead and do this question. I would recommend you to go ahead and pause it, try it out for yourself. Now this question over here says that if x, y and z are integers, right? And x into y square upon z is a positive even number, right? It's a positive even integer. Understand this one thing. When I say even, I automatically imply an integer, right? Because a even number can never be a fraction. Which of the following must be true? Now it says that x square y upon z is a positive even integer. Now y square is always going to remain positive, right? That means x upon z will, for this whole thing to be positive, x and z should be carrying the same signs, isn't it? X and z should be carrying the same signs for this whole thing to be an integer. So that's one thing that I can actually do it from here, right? Or what you can do is, it says that it says x into y square upon z is a positive even integer. Since it's a which of the following question, why don't we plug in once and eliminate the most obvious answer options rather than we trying to interpret things here, right? So again, I'm showing you my thought process. I'm doing these questions for the first time. So I just want to show you how I think, right? So I might go a little haywire, and but automatically I just want to show you my thought process. So it says that x into y square upon z is a positive even integer. So x into y square upon z is a positive even integer. So let's suppose x is equal to 2 and y is let's suppose x is equal to 3, y is equal to 2, and let's not say y is equal to 2. Let's suppose x is equal to 3, y is equal to 4, and z is equal to 2. In this case, what will happen? X into y square is a positive even integer that will hold true. Now, can I make x even? Yes, I can do that. I can make x to be equal to 4. I can make y to be equal to 3, and I can make z to be equal to 2. That's fine. Or I can make x to be equal to even, and y to be equal to odd, and z to be equal to odd as well, right? That's again gonna satisfy, again gonna make this a positive even integer. Now let's check. He says x into y is even, right? It says that x into y is even, but that is true in all my cases. Second, he says x into y is greater than 0, right? That is also true in all my cases here. Third one says that z is an even number. Well, I just disproved using this value. That means this is eliminated. Now I'm down to these two answer options, guys. Now I should not conclude here because numbers are never helpful to conclude. Remember that. When you want to conclude, use algebra. Now xy is even. Will that be true all the time? Yes, that will all be. Because if xy is even, then only this whole expression is going to be even. That means this will always remain true. Now he says that xy is greater than 0. Well, that's not true because y can be -4, -3 and -3. Why? Because y square is positive. Y squared, it doesn't matter what sign y carries. That means this is eliminated, which means one only is true. That means my answer is option A. Right? So suppose you're understanding what I'm doing here. He says that if x, y and z are integers and x into y square by z is a positive even integer, which of the following must be true? That x into y will always be even no matter what. It's not true. It's not always true that x into y would be greater than 0. It's not always true that z is an even number. We cannot disprove here. Right? So I suppose you're understanding this point here, guys. Moving forward, right? Okay. Again, understand, it's very, very easy to fall for traps when it comes to these kind of questions. So make sure that you double check your answer with different ways of solving. So it's very important to stay calm in these kind of questions because they look easy, but they're tricky, right? So it says that x and y are integers and 10x plus y is odd. Now, if 10x plus y is odd, x into 10 is going to be even. That means y is definitely an odd number, right? He says which of the following must be true. That means y is definitely odd. That means C is my answer. Even if I want to disprove this, I can say that let's suppose x is equal to 2 and y is equal to, let's say, 3, and x is equal to 3 and y is equal to 3. Now it says x is odd. Well, I just proved x is even. This is gone. He says x is even. I just proved x is odd. I just proved x is odd. Gone. This is definitely true in both of my cases. Y is even. That is gone. X and y are both odd. That is also gone. So you can plug in also and get your answer. Right? So suppose you're understanding this, what we're using here, that even plus odd is equal to odd. This is something that is very extensively used here. So suppose you're understanding this, guys. Okay. Now let's do a small little concept here, right? So I'm just going to rub this board and do a small little concept. Now let's suppose if I talk about, so just forget about the question totally. Let's suppose I say that I'm talking about sum of consecutive integers, right? Let's suppose I'm talking about sum of consecutive integers. So let's suppose what is the sum of any two consecutive integers. I want to talk about sum of any two consecutive integers. So if the first number is even, then second number would be odd, the sum would be odd. If the first number is odd, the second number would be even, the sum would be odd again. So that means no matter what I do, the sum of any two consecutive integers like 2 plus 3, 5 plus 6, 21 plus 22, the sum will always be an odd number. That means sum of any two consecutive integers will always be an odd number. Let's talk about any three consecutive integers. Well, if the first one is even, second one is odd, third one is even, then the sum is going to be odd. If the first one is odd, second one is even, third one is odd, that means the sum is going to be even. Now in this case, it's possible for me to have odd as well, it's possible for me to have even as well. That means this doesn't give me any type of conclusion. Now let's talk about any four consecutive integers. So if the first one is even, second one is odd, third one is even, fourth one is odd, the sum always comes down to be even. If the first one is odd, second one is even, third one is odd, fourth one is even, the sum again comes down to be even. That means sum of any 4 consecutive integers is always going to be even. Similarly, sum of any 6 consecutive integers is always going to be odd. Sum of any 8 consecutive integers is always going to be even. Right? So suppose you're understanding what I'm trying to do here. It's that sum of any 2 consecutive integers is always odd. 3 I'm not sure, 5 I'm not sure, but sum of any 4 consecutive integers is always even. Sum of any 6 consecutive integers is always odd. Sum of any 8 consecutive integers is always even. So if I just show you here, just want to say that sum of let's not write any here. So if I just generalize this way, that sum of n consecutive integers. Now if n is a multiple of 4, a positive multiple of 4, then the sum is going to be even. If n is not a multiple of 4, but n is in fact a multiple of 2, but not a multiple of 4, then the sum is always going to be odd. Right? So sum of any 16 consecutive integers is going to be even, but sum of any 18 consecutive integers is always going to be odd. Right? So suppose you're understanding this, because things don't get evened out when I talk about the 2 consecutive integers of 6 consecutive integers. It gets evened out in 4 and 8 and 12. So that's the pretty much standard behind it. Right. So let's do some question here on this. Now it says that if x is the sum of y consecutive integers and p is the sum of q consecutive integers. Now for each of the following value, it is possible to have x equal to p except. Well, I would choose this answer option C, because if x is the sum of any 2 consecutive integers and p is the sum of any 4 consecutive integers, then x is always going to be odd and y will always be even, and it is not possible for me to have odd equal to even. Right? Sum of any 2 consecutive integers is odd. Sum of any 6 consecutive integers is odd. That means this is eliminated. Sum of any 3 consecutive integers can be odd and even. That means this is eliminated. Sum of any 5 consecutive integer can be odd and even. Eliminated. 4 is always even, but 5 can be odd and even. That means this is also eliminated. That means C over here is my answer. Right? So I suppose you're understanding this point over here, guys. We've just done that concept and a question using on it. And these kind of questions, plugging in is not going to help you at all. You've got to know this concept, guys, right? Otherwise, things are a little tricky for you when you plan to solve this, right? So I suppose you're understanding this. So if you go ahead and watch the plugging in one video, I'm just relating this video here. If you watch the plugging in one video, not plugging in one. If you watch the must be could be one video, yeah, that one. If you watch the must be could be one video, in that I have actually explained a question regarding regarding x being the sum of y consecutive integers and p being sum of q consecutive integers. If y is equal to 2 times q, which of the following is true except. So try to solve that question now. Now you would not need to plug in into that question. You can very well easily do that question with this concept here. But again, any given day strategy would be more important than your concept. If you know the concept, strategy is like a car, right? You need a car to move around. But a concept is like, good alloy wheels, kind of a stereo system. So concept help you to become faster, but strategies give you the path to go ahead and solve the question, right? So strategies are like plugging in, must be, could be. All these kinds of strategies will help you to solve the question, but concept will just make you faster. It will not help you to solve the question in the way strategy does, right? So suppose you're understanding this point over here, guys. Moving forward. Alright guys, thank you very much for watching this video, right? So we did these concepts that odd plus odd is even plus odd is odd, and even into any integer is even, and odd into odd is equal to odd, right? Plus we also did that it's possible to divide even by odd. It's not possible to divide odd by even. And plus we also did that if s is the sum of n consecutive integers, if n is a multiple of 4, then the sum will always be even. But if it's a multiple of 2, if not a multiple of 4, then the sum is always going to be odd, right? So suppose you're understanding this, guys. This would be the web address to explore more about us. That is perfect-scores.com. There's a lot of exciting stuff coming in. We are coming up with practice exercises and self-prep courses and whatnot, right? So we have our online course as well, wherein you can come and explore more about us. This would be the Facebook page to like us, and this would be the email address to give us your valuable feedback. We've been loving your feedback, guys. We want more and more. We never stop wanting your feedback. So this would be what the video, guys. Thank you very much, and I'll see you in the next one.